Continuing our review of the periodic table, we want to take a look at kinds of information, the type of information that we can find in each and every one of these boxes here. So if we look at iron, we see 55.847 Fe26 iron. If we look at carbon, we see 12.0111 C6 carbon. So what does this information tell us? So if we want to take a closer look, what we can see is there's actually a bit of information for us. So if we zoom into any box, and I'm just going to pick carbon because we talked about it before. We look in the top left, we see 12.0111. We see a big C. Below that C there's a 6. And then at the very bottom, the word carbon. So a couple things kind of would jump out right away. Start at the very bottom. Written carbon, that's pretty straightforward. That's the name. And then the letter, that's the symbol. So that allows us to kind of jump back and forth between words and the symbols. So we now know that C is carbon. So if we see carbon written somewhere, in our minds we can think of the letter C. Or if we see C as part of the chemical formula, like methane, CH4, that C tells us that there's a carbon there. And remember, since there's no number, that means we've got one of them. So, symbol and name, right there. So the next two things that we can see from this, we've got this number in the top right, in the top left, and then this other number right below it. The lower number, which is also always going to be the smaller number, is the atomic number. This top number, which is always going to be bigger, is the atomic mass. Atomic mass. So one thing we'll notice, everything that we look at on the periodic table, you will see that the atomic mass is greater than the atomic number. So you go ahead, you can take a look at anything you find on there. Oxygen, tellurium, palladium, iron, cobalt, uranium, plutonium, every single element on the periodic table. The number in the top left, the atomic mass, is always going to be bigger than the atomic number. So what are these two numbers? Like, what do they tell us? Well, again, we'll start with the atomic number. And the atomic number ultimately is what it is the number of protons. The number of protons in an atom. And that number of protons defines that atom, defines that element. Defines the element. So carbon, a carbon atom, will always, always, always have 6 protons. If you could somehow go in there and reach out and yank out one of those protons, basically nuclear chemistry, you would suddenly have 5 protons. 5 protons would no longer be carbon. 5 protons would be boron. Similarly, if you were to cram an extra proton in there, so pack it in and force it in there, like you would do in nuclear chemistry, 7 protons isn't carbon. 7 protons is nitrogen. And so this goes back to the idea that this atomic number, the number of protons, that number is unique for that element. So 6 protons is always carbon. 5 is always boron. 7 is always nitrogen. Uranium always has 92. Iron always has 26. Things that just don't change. So the second number then, that's the atomic number. The atomic mass comes about, we calculate that from protons and neutrons. And so that's why that number is always going to be bigger, because we have protons and neutrons in there. So carbon, so we're going to talk a little bit later on why that number has a decimal, and it gets into averaging, and it counts for different isotopes, something else we'll also talk about later on. But kind of right now the important thing to remember is top left, atomic mass, think of it as protons and neutrons. Smaller number, 6, atomic number, that's number of protons, that's what makes an element an element. And then you've got C, your symbol, and then the name, carbon.